Hello, my name is Pasita, and I recently completed Harvard's CS50x course. CS50x is all about learning the foundations of computer science, from coding to algorithms to web programming. Today, I will give you a walkthrough of what I learned, show some examples from the course, and reflect on the skills I gained. So let's get into it. CS50x starts with Scratch, which is a visual programming language. It's a great way to get the idea of passing an input into an algorithm and coming out as an output. You drag and connect blocks to tell the computer what to do. For example, you can make a character move when a key is pressed, or collect items. Even though Scratch is simple, it teaches the core idea of programming logic without worrying about syntax errors. In week 1, we learned C language, which is a low-level language closer to how computers actually operate. CS50 emphasizes how source code is translated by the compiler into machine code, which the computer can execute. We covered variables, loops, conditionals, and functions. A key concept is to pass an argument into a function, which then can produce side effects, where a function can take inputs, do something with them, and sometimes change the program's state. One fun challenge was printing the Mario pyramid using nested loops. This taught me how to think about patterns and iteration. Week 2 focused on arrays. Arrays are collections of values stored in contiguous memory. They introduced me to thinking about data in an organized way. Arrays are often the starting point for more complex data structures and algorithms, and they're really useful when you want to store multiple items in one place and access them efficiently by index. Week 3 is all about algorithms, step-by-step instructions for solving problems. CS50 stresses the idea of passing an input into an algorithm, which can then provide output. For example, searching a number in a list can be done linearly or with a binary search. Sorting algorithms like bubble sort or merge sort, like on the screen, taught me how efficiency matters. We also learned Big O notation, which helps predict how long an algorithm will take as input grows. This was a big eye-opener for writing not just working code, but code that performs well. Week 4 dove into memory. We learned about stack vs heap, how memory is allocated, and how pointers let us access memory directly. This is where functions and side effects really come alive. Passing a pointer to a function can change data outside that function. We also use tools like whilegrind to detect memory leaks. Understanding memory is essential for writing efficient and safe programs. In week 5, CS50 taught us data structures like linked list, stacks, queues, hash tables, and trees. Arrays are simple, but these structures allow more flexible and efficient data management. For example, hash tables let us quickly find information using a key. Learning these structures helped me see how the way we organize data affects how programs perform. Week 6 introduced Python, a high-level language that's easy to read and write. We also got a taste of artificial intelligence concepts, like using Python to solve problems more intelligently. Python allowed us to focus more on problem solving rather than syntax. Here I really appreciated the input to algorithm to output cycle in a more abstract, flexible way. Week 7 focused on SQL, the language for interacting with databases. We learned how to store data in tables, query it efficiently, and understand how programs communicate with databases. This was a practical skill that connects programming to real-world applications like web apps or data analysis. Week 8 was about front-end web development with HTML, CSS, and JavaScript. HTML structures the page, CSS makes it look good, and JavaScript adds interactivity. This tied back to the idea of passing an input into an algorithm, which can produce output, right? User input goes through the code and changes what the page displays. Week 9 introduced Flask, a Python framework for building web applications. Here we connected user input to databases and server logic. This was a full stack example of input to algorithm to output in action, showing how a request from a user travels through code, gets processed, and returns a result. Week 10 pointed us towards the future. We touched on basic cybersecurity and safe coding, then learned how to set up VS Code and command line tools for real projects. David wrapped up with next step resources, like other CS50 courses, coding practice sites like LeetCode, and tech news like Hacker News and The Verge, so we can keep learning long after the course. Throughout CS50x, each problem set gave me a chance to apply theory. Debugging tricky parts taught me persistence and analytical thinking. I now feel confident in writing programs from scratch, solving algorithmic problems, and even building web apps. These skills will help me in future studies and projects. Thanks for watching my CS50x summary. This course was challenging, fun, and eye-opening. I hope this video gives you a sense of the journey through computer science fundamentals. I'm excited to continue learning and applying these skills in real-world projects.